Well, when I entered the University of Malaya, Faculty of Engineering in those days, up in KL, we had a common course, first year, second year. We studied all branches of engineering. It's only in the third year that we have to decide and specialize. And there were only 3 branches of engineering: civil, mechanical, electrical. But you already had a good foretaste of what those subjects are going to be like in the years to come. And I chose civil simply because when I studied electrical, I got high marks, no doubt about that. I could get all the answers correct. I underlined the answers, get all the ticks, and you can get 90% or something like that, no problem. But I was afraid I'll go to the laboratory, I'll get electrocuted. Because the two are so disjointed, you know. The practice part and the theory part, they don't seem to be too well connected, at least in my opinion. I dare not tell the lecturers that. I cherish the fact that I can underline the answer and get it right, you see. It's all mathematics, you see. That's electrical. So I say, no. They send me down to the power station, I'll get killed. So I decided electrical is out. Then came mechanical. Mechanical is a different animal, you know, completely. So they'll ask me to design a power shaft, for example, you know. So you design, use your slide rule in those days, slide rule. So you'll use your slide rule and you'll work it out, and you get maybe 3.5 inches, you know, for a shaft, transmission shaft. Then the lecturer will come and say, 3.5 inches? No. Make it 6 inches, you know, so that it's the right size, you know. Can't have a shaft thin and long that way, even though theoretically it says okay, you see. But you need a good shaft that way. So he overrode me, and he said he's wrong, and all kinds of other reasons. And I said, mechanical engineering is so much guesswork. What's the point, you know, of calculating down to the decimal point when, what's the point, you know, he just comes and multiply it 5 times so that it looks good, you see. So that's mechanical. Then I also realized, who's going to make all this in Singapore, you know? We are a manufacturing hub. All the designs have already been settled overseas by the engineers there, and they only want the production here, you see, because of cheap labor and so on. So you'll end up oiling the machinery. This type of work, I say, no, that's not for me. So it's civil, and I love civil because you connect physically with what you're doing, you know. You build something, you build a bridge, at the end of it, you see the bridge, and it works that way, you see, and the calculations all fall in line. That's what you expect, and so on. So I was very attracted to civil for the wrong reasons, actually. So I chose civil. And it was a good choice. I never regretted. It was a time when I graduated in 66, 67, took the finals in 66, graduated in 67. And by 70, or even earlier than that, it became very apparent to us that water is a critical resource, you know, and we may not have enough, you know. So the Prime Minister, Lee Kuan Yew, in those days, wanted a small unit to be formed. And 3 people were chosen. First, my PERMSEC, Lee Ek Tian. He's my predecessor in the same faculty. Unfortunately, you know, he's not able. The PERMSEC, and next was his deputy. And I was a very junior engineer in those days, 2-3 years experience. But I came up with a good degree, so they wrote me in, you see. So 3 of us formed what was called the Water Planning Unit in those days, reporting direct to LKY, Lee Kuan Yew. It was a turning point for me because there's so much for me to learn in water resources, which the university never taught in those days, you know. They are too busy with many other issues. water was the last issue for them. But for Singapore, it's a matter of survival, actually, you see. So there's so much to be done in water resources in those days. Fortunately, that is a field also which is open for you to think through. You know what I mean? It's not a crowded field where everybody has thought about it and so on. But it's an open field. Nobody bothers too much about water, especially in Malaysia and so on. And it is there that I found that you cannot solve the water problem, technically speaking, just by having pen, paper, and try to work it out. You can't, because the data that you need to handle is so enormous. I mean, daily rainfall data for 60 years, that's the record, and how to simulate it again and again to find the optimum size of reservoirs, catchments, and so on and so forth. And data is too short. You got to find what are the statistics that govern the generation of this data, then use random number generation and generate more data so you can get 1,000 years of data before you can analyze it. And you cannot analyze it using pen and paper with so much data. You need to simulate it and so on. So there's a lot of computer work. And computers in those days, they are in their infancy, you know, way back in the 1960s, especially the use of computers in engineering, you see. So I got to study how to program a computer, which I never did. The other two, Li Tian and Li Hongxiang, my seniors, they have given up long ago about computers. But I was supposed to be the smart young engineer from the university, and I should know something or know enough. But unfortunately, the University of Malaya never taught me anything about computers. So I learned how to program the big size computer, and then laid the foundation for the generation of more data, analyze the data to form the water master plan for Singapore, all to be done in 3 years, and then write the report to go up to the PM to do the explanation, you see. So that was a pivotal moment to join the water planning unit and come up with a water master plan for Singapore within 3 years and make a presentation to the PM. And I remembered the presentation very well, you know. It's like it was yesterday. 3 of us chosen to form the unit. We went to see the PM at the end of 3 years, and the head of the unit, the pump side, when the PM says, okay, do your briefing, he looked at his deputy, and his deputy looked at me. I was the last one in the row. So I got the fright of my life. But being a young engineer, so what, you know? They don't like you, they just tell you, look for another job. I'm all ready. I got no stakes, no career to protect and so on. So I gave my best. And after that, yeah, it went down very well. And so we had the water master plan, and it laid the foundation for what we see today, the water master plan. Only 2 copies that PM allowed to be made, one for ourselves and one for him, and no more. All others are to be destroyed. I don't know whatever for. They were destroyed out of the blue, you know. I was a drainage engineer. I was, you know, when I graduated, I did well. Went to see the director of public works. Then I thought I'll be building huge buildings, bridges, and so on. It was nothing like that. He sent me down to the drainage department. We all call it Longkang department, you know, in those days. And the Longkang department's head sent me down to do the maintenance of the Longkang. I said, oh my goodness, not even to build it, but to maintain it. But I spent, let me see, about 2-3 years just making sure the drains are clean and so on. But in so doing, I knew every canal, every outlet drain in Singapore by name, you know. And finally, as things would have it, when the call came for the water, and that was in year 2000, they all remembered I did my homework. So I took over water from the year 2000 onwards in PUB. Well, the department then, the faculty then wasn't called what is called today. I was in University of Malaya in KL. That's where the Faculty of Engineering had gone up to. It was no longer in Singapore. You want to do engineering, got to go up to KL by train in those days. So the most memorable event is this. There were two, and they are related. One was we invited the Students Union invited LKY to go up and appear before the students. I was in my third year, I think. Hours before he arrived, the lecture theatre was full. They were all waiting to see him. Many of them came in by the busloads, They were the UMNO youth and so on. They were all there to question him and so on. We were part of Malaysia, and he was promoting Malaysia and so on. And there were other students who had something else to ask questions. When it came to question time, when he walked into the lecture theatre, LKY when he was young, his face was all the time red, he's flushed, he's ready to answer questions and ask questions and so on, a debate. And so when he walked in, red in the face, they all said, "Mabok, mabok." The whole of them said, "He's drunk." It's okay, yeah. Then came to the question answer session. LKY started by giving a talk about Malaysia, all to be equal and so on and so forth. That's his concept, no? Then when it came to question answer session, I got the shock of my life. I expected them to ask for clarification on Malaysia, but so no. But the first question was from a youth leader from UMNO. He asked PM, he's not the PM at that time, just LKY. He asked LKY, what is your position regarding the sultans in the Malaysia concept? What is the position of the sultan? And I was completely taken aback, completely. It was like talking at different wavelengths, Here is the UMNO youth more concerned about the sultan and his position. We were all concerned about the details of Malaysia and so on. That's our primary area of concern. Will there be give and take here and there, and what will we be in for? None. It was about the sultan. And I said, my goodness, if we carry on like this, talking at cross wavelengths and no meeting of the minds, then I think it just won't work. LKY got their thinking wrong. They got LKY's thinking completely wrong. And how are we to get together that way, you see? Then came next year after that. Still, I was doing my final year then. It was after dinner and we all gathered. I was in the fourth college in University of Malaya. After dinner, students all gathered to watch TV for half an hour or something like that. Then to my surprise, we sat on the floor. To my surprise, here came LQI on the screen, He announced Singapore has been booted out from Malaysia. He was crying and so on. And I got the fright of my life also, Such a memorable event captured on TV, played there before me, right in the Faculty of Engineering. I suddenly felt that classmate of mine who's not from Singapore, from Malaysia, hey, these are foreigners. I'm studying engineering in a foreign land. I'll be returning back to my hometown, home country. I better study hard, do well, go back, Suddenly, the alienation between students took place, and that was very memorable. These two events, he announced about it, and I said, oh my goodness, what are we to survive on, We got something like 1.5 million mouths to feed, no jobs and so on. no army, no defense. In fact, later on we heard there's a column of tanks going down the trunk road towards Singapore. That column of tanks was led by a General, Winston Chu, and he was headed for Singapore. Whether was he there, whether is there going to be political turmoil, and he's heading for the Istana. And we said, oh my goodness. But later on, to our relief, he submitted himself, Winston Chu submitted himself to the civilian government, and we all breathed a sigh of relief, Those were memorable events. You see, we did the first water master plan way back in the early 70s, and I led the way because of computers and so on. That's okay. Because I was a young engineer, I could dream dreams, So I dreamed of the day where, after the first, it's a 3-year study program. After the first year, we all realized we will never have enough water, natural water. That somehow or other we need to find a different source of water, apart from the imported water from Malaysia. And the only solution actually is water reuse in a closed loop system. Water reuse in an open loop system, everybody knows. The household, the factory will discharge the wastewater for the farmers to take up, to use, and so on. It goes downstream, and finally it goes out to the next city, all the way down to the sea. Then you can say it's water reuse, but in a closed loop. In an open loop system, you see. But the exciting thing I found in the water master plan is water reuse in a closed loop system. We are able to recover the water, treat it to a potable standard, and reuse it, And the mathematics of it is similar to that we studied in electronics, The feedback system, the shrieking noise you hear when there's a feedback in an audio system, that's because what you say got caught up by the amplifier, amplified once more, it goes round and round that way. The more sound it collects, the louder the shriek. So there's a exponential impact on the ability to supply the water if you're able to recycle it that way. In fact, you can recycle every drop. You don't need the natural water, you see. Of course, it's impossible. But even if you were to recycle, say, 3/4, then a reservoir that you are able to recycle, say, 3/4 of the wastewater, you polish it up and send it back to the population. Then for that particular 100 million gallons of water you have, you can supply, 400 million gallons, 4 times the original supply of the reservoir, because it multiplies that way, you see. So for 3/4 of recycling, you can supply 4 times what the reservoir could normally do. Wow, that is it, you see. Because if you can do that, then you would have solved the water problem for Singapore. Natural water, not enough, recycle the water. Then if you can dissolve the water, you add more to it, you see, because that dissolved water can again be recycled. So you have an enormous amount of water, you see. But that was only a dream I had when I was doing the first water master plan. There's no technology that can do that. We had waited something like 30 years until the year 2000 before that technology became apparent that it can be done. We got the digits there. All we have to do is to assemble it, optimize it, make sure that it works on the laboratory scale. Then there you are. We can do it that way. We were following the research done in Orange County in the US, which is very well known for water reuse. And they were experimenting along those lines. We didn't have We didn't have to do it ourselves. They got all the PhDs there to try to do it. We were just having to follow behind them in knowledge. But once we could see the daylight through it, we poured in the money. We are a single-tier government. We don't need to get, provincial approval, then countrywide approval, then go up to get federal, and that'll take years. We are a single-tier government. Just we and the government, we decide and we move on. So that's what we did. So we caught up, overtook them, and we were the first to produce what today we call new water. That I would say was what we discovered. I wouldn't say it is a new technology. It's just putting in those technologies that didn't work last time because of manufacturing issues. But today, by the year 2000, it can work because manufacturing technology has improved tremendously, prices are coming down, and therefore it is feasible. We call it membranes today, but in those days, membranes were, we tried this type of technology, In fact, we built the first plant successfully. Some of us even drank the reclaimed water, which is potable, reached WHO standards, but the technology, manufacturing technology, has not matured yet. In other words, every few days the membrane will leak, will break down and so on, and you can't build a municipal plant running that way, It's like me making a car for you, and every week you go to the workshop, you say, how can I use it that way? You must run at least 6 months, you see. So it's the manufacturing. So once the manufacturing of all these components are okay, reach a certain mark, we know we can succeed, you see. That was the year 2000. So it took us something like 30 years waiting for that idea to become a reality, Well, you all know it just as well as I do. Artificial intelligence is going to lead the way in all its varied forms. But leading the way would be neural networks. The neural network where you can train it, and by self-learning it gets better and better. And the neural networks that we experimented with in the early days, they were what we have in a handphone today. You use the handphone often enough. I want to call my wife. I just have to say a few words, and all the other words will come popping up for me to press and say, that's the word I want. It's because of the neural network that must have been built into the handphone, and by constant use, I've been training the handphone, what's the next word to expect, and so on. Neural networks, that way. So I think the bulk will be in this area, expanded. That will be leading the way, The trouble is, not only engineers, scientists can do that. So many other areas will be encroaching upon the area that we thought should be the domain of the engineers. That even as new areas of engineering are discovered, the basics of engineering must never be forgotten. And the basics, actually, if you think carefully, is just common sense, That's what I've been telling all my colleagues, It's just common sense. Don't ever forget that. And you'll be surprised in life, as you go through life, you find that actually common sense is not so common, Not so common. But it's there in basic engineering, civil, electrical, mechanical. You're dealing with human beings at the very basic level, common sense, We must never lose that. Even though we may branch out into AI, artificial intelligence, and all these other areas, I wish the engineer will never forget his basic training. And he has seen me through so many other areas in life. I've been through the train system. Now I'm with the airport, Changi Airport. I've been through the water system, many other environmental systems. And the basic issue is, maybe I call it systems engineering, systems thinking. to be able to think through a big issue, identify which are the critical areas, pour in the research in those areas, and get the solution out. For your department, I know you now have civil and environmental engineering merged together. Environmental engineering is very broad-based. You can go to many other areas. But my hope and my wish for your civil environmental engineering department is don't forsake the teaching of basic engineering. It trains the mind more than what you taught. And it is the training of the mind that will see you through the challenges of life. And that's my wish for the civil and environmental engineering department. Thank you.